Hello to everybody. I'm happy to greet all the participants of the conference on cloud and immersive technologies in education. The topic of our presentation today is the development of the information system for navigation in modern university campus. I am happy to greet the authors of our work. There is Professor Lyudmila Gryzun, it's me, my colleagues, Professor Alexander Shcherbakov, and master student Bogdan Bida. We are happy to present Information Systems Department of Simon Kuznets, Kharkiv National University of Economics, Kharkiv City, Ukraine. We are going to cover urgency of the research, theoretical framework, stages of the system development, results, discussion, and prospects of our work. So the urgency of the work is caused by some factors. Modern universities today are important educational, scientific, and cultural hubs that are daily attended by a large number of people on different purposes who are unfamiliar with the location of its buildings and their topology, and have a need for convenient navigation, which makes urgent the design and development of the appropriate information system for navigation. It's necessary to search, on the other hand, efficient solutions for scientific and applied problem of indoor navigation, which has been getting urgency recently, but hasn't been solved in full measure. Indoor navigation as a problem means detecting objects and orientation inside of the buildings using radio waves, acoustic signals, wireless networks, and other means. The challenge of such navigation is that each building where it's necessary to orient must have special devices configured to work with the navigation system. It makes the development of such a system expensive and long-term, and also adds certain difficulties to its testing, maintenance, and expansion opportunities. On the other hand, indoor navigation technologies based on the processing of visual images as well as QR codes are underused and forgotten nowadays, although they require less investments and have significant prospects and advantages. In addition, the analysis of the functionality of existing systems for indoor navigation testifies their limitations which cause the search of different approaches. The theoretical framework is made by the analysis of the applications which realize similar functions of the subject domain, the approaches to solving the mathematical problem for the shortest path searching graphs, and technological solutions of digital maps builder. So in terms of the analysis of the facilities of the selected services of indoor navigations, we have to admit that we analyzed set of them according to some criteria which you have on the screen. Their route building functionality, adaptability of the interface, price, and many other criteria. Based on these criteria, we analyze the facilities of selected services of indoor navigation, which are used all over the world in different universities and in different establishments. The result of our analysis, we have to conclude that despite the significant functionality, these indoor navigation services have the following set of limitations. Most of the analyzed analogues are able to provide navigation inside a specific building, but they are not suitable for use in other premises. At the same time, they do not have a sufficiently developed functionality for extension and refinement. They do not provide users with language localization, and they are either web services or mobile applications. So this limitation cause the search of appropriate algorithmic interface and technological approaches to design of information systems, and they will take it into account determining the functional and non-functional requirements for our system. In terms of algorithmic solution, we analyzed the problem of finding the shortest path, and to solve the specific practical problem, An appropriate analysis was conducted to select an adequate search algorithm among such well-known algorithms as Dijkstra, Bellman-Ford, Floyd-Warshall, and other. The main selection criteria for this problem are the properties of the graph as well as the execution time of the algorithm. As a result, there was selected Floyd-Warshall algorithm, which works based on the dynamic programming methods. In terms of found interface algorithmic and technological solutions, we would present the following. It was done the specification of functional requirements based on the analysis of the use cases. In particular, the set system for navigation has to supply for a user such facilities like language localization settings, selection of existing location on the interactive map, determining the location of the user, and the set of other important functional requirements. So due to these requirements, we try to find out technological approaches, and technological instruments were selected like this one: Angular as a framework for SPA web apps development, and the set of libraries. The general architecture of the navigation system was elaborated. As you can see, there is the system of 4 interconnected modules: the graphic module of detecting users' location, shortest path search module, and the module for the visualization of the searched route. Graphic module plays a key role in the main architecture of the system. It serves as an intermediary between the user and the entire logic of the application, including data processing and execution of complicated algorithms of detecting the user location and visualization. It provides not only the appearance of the application together with the means of interaction, but also the logic of interaction of data related to the visual part of the system. It is the set of interface elements and program code. And in terms of the approaches to development of the graphic module, they were selected basic main principles like implementation of the interface control components in the form of the special files, implementation of the adaptive user interface as a grouping of all control elements with additional display logic, and some others which you can see on the screen. So the interface solutions also include the interactive map generation by digitalizing flow layout of university premises with the use of editor Adobe Illustrator. The results of such digitalization are used for interactive maps building, and sent to the application of vector graphics. A map was obtained for each flow in the form of a document with its own syntax and rules, which describes the corresponding graphic elements of the image using attributes and formulas. This provides dynamic interaction with such a document using program code, and it has advantages in terms of loading speed and image quality, and adaptability and flexibility of the whole navigation system, which is really important. So in terms of algorithmic solution, the key role is played by the shortest path search module. Its architecture you can see on the screen. So as a result of the development of all of the components and all of the modules of the system, the functionality of the university navigation system can be characterized as following. It allows free viewing of the scheme of the university premises, change of the current flow, change of map scale, finding the shortest route from the start point corresponding to the physically located QR code to any accessible university location, scanning of QR code, code, central the map, localization of the user interface in 3 languages, and some other functions. Among them are important additional functionality like facility to scan QR codes with third-party software to move to the navigation system, the ability to download a web application to a mobile device from the user's browser and use it in similar way as native application, even offline. In addition to the location of the QR code itself, a user can also put any final point or start point in the QR code, and this significantly expands the areas of use of QR codes for our system. The episodes of work of the navigation system with some built routes you can see on the screen. So the navigation system was implemented into the educational practice of Simon Kuznets National University of Economics. QR codes were placed in relevant locations of the university premises, which enables university visitors to access the system with their smartphones and use the functionality. Feedback from the system users was collected and analyzed. Users were asked to fill in a survey form evaluating the quality of implementation of functional and non-functional requirements for the system on 5-point scale. So you can see here the QR code to access the application and QR code for the form. As a result of the analysis of users' feedback, they were elaborated the ways of the system improvement. Mostly users gave positive feedback, but among wishes there were acceleration of application loading, implement the possibility of sharing a link with an already built route, and to provide the quality of the animated visualization of the laid route. All of the implementation improvements were done, elaborated, and implemented. And in terms of conclusion, we would like to say that in the progress of the work, there was developed the navigation system, which was implemented into the educational practice of the university. Thanks to the proposed algorithmic interface and technological solutions, during the design, it was possible to overcome the main limitations inherent in similar systems implemented indoor navigation. The assessment of navigation system in comparison with other analogues makes the prospect of our research. Thank you for your attention, and we are ready to answer your questions.